In this video, we'll look at the process of determining a sample size and acceptance number for a three-class concentration-based sampling plan using the calculator in the three-class concentration tab. The cells that are shown in orange are those that accept user input, and we have various areas as usual that we'll just quickly have a look at. At the top, we've got an area for specifying the sampling plan, including the sample size, the acceptance number, the standard deviation on the log scale, as well as the two microbiological limits, little m and big M, both also on the log 10 scale. The corresponding OC curve is shown down here at the bottom. There is also an area for a point of interest, which allows you to calculate the sampling plan's probability of acceptance and rejection for any mean log 10 concentration that you might be interested in. And we have a different video that shows you how to use this. There is also an area at the bottom here for specifying the consumers and producers risk points, and there are several additional graphs on the right that provide some further information. So let's now have a look at how we can develop a sampling plan from a statistical basis that meets a consumer's and producer's risk points. First, we need a reasonable estimate of the standard deviation. Now, you may be able to obtain an estimate for the variability from historical data, from published literature for similar products, or by collecting a few sample units as part of a pilot stage. You also need to decide on values for these limits, the marginal limit little m and the unacceptable limit big M, though these are both business or risk management decisions rather than statistical ones. So for this demonstration, let's assume that the standard deviation is 0.55 and that the microbiological limits are little m are 500 on the original scale, and therefore on the log scale we type log 500, which comes out at about 2.7. And for the unacceptable limit big M, we use 5,000 on the arithmetic scale, which on the log scale equals log of 5,000, or about 3.7. Now, as starting points for any particular plan, we can pick any reasonable sample size. So let's just keep it with n equals 5. And let's pick a small value of C of 1, which in fact is the smallest value that we can have, because a value of C equals 0 basically says that we are not allowed to have any marginal items, let alone any unacceptable items, and therefore the three-class plan is essentially a two-class plan. And now we need to specify our consumer's risk point. Again, this is done by providing a worst case type of mean log 10 concentration and a corresponding probability of acceptance. Now let's say that we have values of 3 and an associated probability of acceptance of 10%. This also provides us with an arithmetic mean of 2,230 almost, and the point is displayed down here at the on the OC curve. The current plan that we have with n equals 5 and C equals 1 has an actual probability of acceptance of 2.42, which clearly meets our maximum probability of acceptance specified as part of the consumer risk point, which is 10%. Now, this actual 2.4% is quite a bit lower than the 10% that we have specified, and we might even be able to relax this sampling plan and reduce the number of the sample size from 5 to 4. This still meets our consumer risk point, so let's drop it down one more, but dropping it to 3 no longer does. So the smallest sample size that will meet our consumer risk point in this case is 4. At this point in time, you're basically finished, unless the sample size that you've calculated here is in fact too large for practical reasons. And in this case, you would want to relax either the mean by increasing it, or the probability of acceptance by also increasing it, or possibly by increasing both of these criteria as part of the consumer risk point to make a plan with a smaller sample size more likely to meet this risk point. However, you may also want to have a look at the OC curve at lower mean concentrations, and in fact it may be appropriate to specify a producer's risk point. So what would happen if we had a consumer's risk point where we had a mean concentration on the log scale of 2 and an associated probability of acceptance of 95%. In this case, the actual probability of acceptance is just lower than the 95% that we specified, and hence why the color here is in red. And you might say that this is close enough and that you don't want to do anything else and just leave it at this. Alternatively, if these two probabilities were in fact further apart, or if you really want the actual probability to be greater than 95%, then what you would have to do is increase the acceptance number to 2, which will shift the OC curve to the right, and while the producer's risk point is now met, the consumer's risk point is no longer met. So again, a very similar process as we had for the 2-class plan. We have to increase the sample size from 4 to 5, and by the time we have a sample size of 6 and acceptance number of 2, both of these risk points are met. The actual probabilities are now shown in green, and we have found a sampling plan that meets these risk points. In practice, you may have to alternate between these a little bit more often, and remember that you may actually end up with a sample size that for practical reasons is just simply too large, in which case you need to look at reducing or relaxing the producer's risk point, shifting it to the left, or increasing, also relaxing the consumer's risk point by shifting it to the right, or possibly by doing a combination of the two.